Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider LHC, operated by CERN, is a 17 ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine designed to unlock the secret of the universe hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations with 23 member states and thousands of scientists. It's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack not for cars or horses, but for subatomic particles in a race against time. In space itself, the LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors. Atlas, CMS, Alice, and LHCb each serves a unique purpose, exploring different aspects of particle physics together. They act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm, but with every answer comes a new question, and with every discovery a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist also went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept, it's a tangible reality within the LHC. The temperatures, the pressures, the raw energy all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of resistance itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go terribly wrong. Back in 1978, the Russian physicist Anat Borsky experienced a disaster that would forever alter the course of his life while working on the U-70 synchrotron at the Institute for High Energy Physics in Pau, Russia. A malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction burning through tissue and bone, yet astonishingly Borsky remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized TI death, leading to the loss of hearing in one ear and partial facial paralysis, yet astonishingly Borsky's intellectual capabilities remained intact and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated. These are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity even on a microscopic scale is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Those scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly. The mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight and then a heavy weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very, very high energy levels. The respected British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book on humanity's future, he explored the potential hazards linked to particle accelerator experiments, including those at CERN. His words were not mere warnings. They carried an air of existential dread. He discussed a worst-case scenario in which an ill-fated experiment could produce a phenomenon called vacuum instability. This instability could, in theory, initiate a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns weren't limited to theoretical speculations. He assigned a probability to these disastrous outcomes, albeit a low one. However, even a tiny chance, he argued, should give us reason to pause. The stakes are unfathomably high, and the margin for error is razor-thin. Scientists at CERN have calculated the probabilities, conducted simulations, and scrutinized the theories to assert the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of cautious exploration, recognizing that widespread fears and concerns surround the activities of the LHC. He stressed that rigorous safety protocols are in place, comprehensive reviews and guidelines that the LHC operates with the utmost precaution. Cox assured that the energies involved are well within what the Earth naturally experiences, and the likelihood of creating a stable black hole is astronomically low. Even if one were created, scientists claim it would be so small and unstable that it would evaporate in a burst of energy, a phenomenon predicted by Stephen Hawking. Known as Hawking radiation, it would be a fleeting moment of cosmic wonder, an instant glimpse into the void, and then gone. Some have gone further, suggesting that the LHC's experiments could open a portal to another universe or dimension, though this idea has largely been dismissed by the scientific community. It has captured the imagination of many and has become a topic of fascination, fear, and even legend. What lies beyond our reality? Could we unknowingly release forces or beings that we don't fully comprehend? The concept of opening a portal to hell has even been sensationalized in various media, fueling uncertainty. But how did this idea arise, and what does it signify in the context of scientific inquiry? The idea of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, proposes that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compacted or hidden from our perception, but they might be accessible or revealed under extreme conditions. Now envision the LHC as a cosmic key unlocking doors that have remained sealed since the dawn of time. When protons collide at energies never before reached on Earth, they could create conditions that momentarily expose these hidden dimensions. Could such a rupture in the fabric of spacetime allow for the manifestation of strange phenomena, entities, forces, or even realities beyond our comprehension? This leads to the question, what concerns work signify for humanity's future? Are we tampering with forces that we should leave undisturbed? Are we on the cusp of a new chapter in our understanding of the universe, or have we unleashed powers beyond our control? No one can answer definitively. As Brian Cox pointed out, we are embarking on an expedition into the unknown. How we navigate this new frontier and the responsibilities we carry with this knowledge will shape the future of humanity. As we peer into the abyss of creation, we must ask, can we handle what we discover? Let us know your thoughts in the comments below.